everybody. I just thought it'd be appropriate to, since it's the last day before Easter break, to come across as a bunny. Look at my ears. This is the last lesson. You do not have homework for the next week, obviously, because it's Easter break. So I hope you guys enjoy your time with your family. And this is the last lesson you got to do before Easter. Talk to you in a bit. Bye. All right. That was Miss Starkey the Easter Bunny. All right, now we're on lesson 15. We're getting there, okay? Again, a little bit more on exponents. So let's get started. Let me make this a little bit bigger, hopefully, so I'm not messing that up. All right, I'll move it over when we need to. All right, so this one says, find the values of 3 to the x power and 1/3 to the x power, and what pattern do we notice, okay? So I'm gonna do these kind of this way. If I have 3 to the x power and x is 1, that means what is 3 to the first power, okay? Which is 1, 3, which is just 3, okay? A little different colors. Okay, if I did 3 to the second power, this is, if this is 3, if my base is 3 and it's saying x is 2, remember that's 3 times 3, which is 9. Okay, that's this one. If I do 3 to the third power, it's 3 to the third power, base of 3, x is 3. 3 times 3 times 3, okay? That would be 27, because 9 times 3 is 27. And then the last one on here, if I do 3 to the fourth power, okay, that's just one more 3. 3 times 3 times 3 times 3. 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. Okay, and when I multiply that out, I would do 27 times 3, because 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, so that's just showing you if I can have an x as an exponent. It just means that whatever x is, I raise it to that power. All right, I can do the same thing with fractions, okay? Not any harder. So what this first one means is it actually means, and I'll use pink again, this means 1/3. The reason it's in parentheses because the whole thing is to the first power, okay? That just means 1/3. 1/3. Okay? If I do 1/3 to the second power, when x is 2, I would do 1/3. Again, the whole thing, because I'm raising the whole thing to the second power. This would be 1/3 times 1/3. 1 times 1 is 1. 3 times 3 is 9. And you should start seeing a pattern. Okay? If I do 1/3 to the third power, just substitute in 3 for x, I get 1/3 times 1/3 times 1/3. And I get 1 times 1 times 1 is 1, not 3. 3 times 3 is 9. 9 times 3 is 27. So that gives me 1/27. You can probably, without doing the last one, figure out what it's going to be right now, right? Just looking at the pattern. So this would be 1/3 raised to the fourth power, which is 1/3 times 1/3 times 1/3 times 1/3. And again, 1 times 1 is 1, times 1 is 1, times 1 is 1. Still 1. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So this one is 1/81. Okay, what do we notice about that? Okay, you should notice that they are reciprocals of each other, okay? Because 1/3 is a reciprocal of 3. Remember, reciprocal means you flip it. So 3 can be written as 3/1, okay? And this is its reciprocal. So 1/3 is the reciprocal of 3. So anything I raised to a power was going to be the reciprocal of that number, okay? So you should notice out of here that they are reciprocals. All of them are reciprocals of each other. So this could be written as 3/1. Flip it, it's 1/3. This can, as a fraction, is written as 9/1. I flip it, it's 1/9. 27/1. Okay, as a fraction written, any whole number you put 1 under it, 1/27. So you get the pattern, okay? That's what that's just trying to show you, that if I square the whole thing, I'm going to get the reciprocal. All right, now this one, it says evaluate for the expression of x, okay? So what it's telling me is where there's an x, I'm going to put in a 10. Now you have to be very careful with this because 3x is not going to be 310. You got to make sure you put the symbol in. Remember 3x means 3 times x. When I write it out, I've got to put that symbol in. So I would do 3 times 10 squared, okay? And then I've got to do order of operations and figure that out first. So this would be 3 times, I'm going to use a parenthesis, 10 times 10, okay? Order of operations said I was doing that first. That's 100 times 3. I get 300, okay? So it's just taking your value and substituting it in for x. All right, if I do the second one, it's the same thing, 3x squared, but this time x is 1/9. So I'm going to write it out first as 3 times 1/9 squared. I have to put parentheses around it because the whole 1/9 is squared. I'm going to write it out, 3 times 1/9 times 1/9. If I do 1/9 times 1/9, I do 1 times 1 is 1. 9 times 9 is 81. I still have to multiply it by 3, okay? This would give me 3 over 81. Remember, make that a fraction. Now I would have to reduce it. 3 goes into both of these. So I'm going to get 1 over 81 divided by 3 was 27, if you remember. Okay? All right, that's how I would do that one. I'm probably going to be using up a lot more. That's why I'm using different colors because I'm writing kind of big. All right, so this one, it's saying it's x to the third power divided by 4 when x is 4. So I'm going to write it out as 4 to the third power over 4, okay? Now, if I write that out, I would do 4 times 4 times 4 over 4. All right, the easiest way to do this, I can multiply that out and divide it, but we have cross-reduced fractions. If 4 goes into this one once, 4 can go into one of them once, okay? I just have 4 times 4 and I get 16. Now, I could have done 4 times 4 times 4 and I would have got 64 over 4, and I'm still going to get 16. I would just divide that out. But if I cross-reduce, it's a lot faster, okay? This one's going to be a little bit tougher just because it's a fraction over a fraction, okay? So I'm going to write it out. I've got 1/2, x is 1/2. I'm raising it to the third power over 4. Okay, so I'm going to leave it like that right now. I'm not going to try and fix anything yet. I'm going to multiply this out. 1/2 times 1/2 times 1/2 over 4. So all I did is put that out in expanded form. 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8. So now I've got 1/8 divided by 4. Okay, that is the same thing as 1/8 divided by 4. Remember our keep, flip, change? That's what we would do right here. Keep, flip, change, KFC. I would do 1/8. I'm going to flip this. Remember that would be 4 over 1, so it's 1 over 4. And I'm going to multiply. And I get 1 over 32. So all I did is write that out. This just means divided by, okay? So I wrote it out this way because that's the way we did our fractions, okay? And then I wrote it out as a division problem, and then I did the keep, flip, change and made it a multiplication problem. And I ended up with 1 over 32, okay? All right. All right, so this one, what I'm going to do is, I lost my train of thought for a second. I hate when that happens. Sorry, I forgot what I was doing. All right, so this one, I've got 9. Oh, this one's tricky. This one messes up so many people when I give tests, okay? This part doesn't. 1 to the 7th power, okay? That's how I would rewrite that out. It says x is 1, I'm going to 1 to the 7th power. This is not 1 times 7. This messes up so many people. This is 9 plus 1 times 1 times 1 times 1 times 1 times 1. 1, 2, 3, 4, 5, 6 times 1. All right, you all know what 1 times 1 is. It's 1. If you multiply that by 1, it's still 1. If you multiply that by 1, it's still 1. So this whole thing is 1. Anytime you multiply any number by 1, it's 1. So this is really 9. I don't want to put that. That's on a division bar. Plus 1, and that's going to be 10. Okay? 1 to any power always messes up a lot of people because you think it just looks like it should be 7, but it's not. All right, and then the last one. This is 9 plus x to the 7th, which is 1/2 to the 7th power. All right, it's just kind of a pain because it's going to be long. 9 plus, I'm going to have 7 of these. 1/2 plus 1/2. Oops, times, not plus. What am I doing? Times 1/2 times 1/2. That's 4. That's 5. That's 6. That's 7. All right, my easy part is going to be my 1s. 1 times 1 is 1, times 1 is 1, times 1 is 1. I'm going to get 1 on the top. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. So I always do the little thing so that I don't mess up where I was. I did this was 4, okay? All right, that's not my answer though, because I still have to add on 9. So this is going to be 9 plus 1 over 128, which is going to be 9 and 128. Okay, so all it's having you do on this part is substitute in the number for x and then either take it to that power or raise it to that power. So you really have to write all of this out. You are not going to be able to figure these out in your head. The easy ones, yes, but you still have to write them out, okay? Because they do get harder and you would get lost trying to do this, okay? Remember, it's not 2 times 7. It's 2 times itself 7 times, okay? So I need you to write all that out that way, okay? All right, let's go on to the next one. All right, so this one's a little different. It's giving you a list below here, okay? It says find a solution to each equation in the list. Numbers can be used more than once. So it's giving me a list at the bottom, okay? And then it's giving me a problem. Now, I can do one of two things. I could say what times itself is equal to 64. So this is really 64 equals x times x, okay? Hopefully we know our times tables for that. If not, I'm guessing it's one of these numbers, okay? I know that 8 times 8 is 64. So in this case, I would say x equals 8 because 8 times 8 equals 64. Equals 64, or 8 to the 2nd power equals 64. Okay? That makes sense? All right. Our next question is saying I've got x to the 3rd power, and that equals 64. So I'm saying, okay, well, some number is going to equal x times x times x. All right. Think about it this way. You need to have a factor of 8, okay? Or a factor of 64 or a factor of 8 in order for this to work. So if I look at my numbers, 6 isn't going to work because 6 times 6 is 36, times 6 is too high. 5 is not a factor of 64. It doesn't go in evenly. 4 does, okay? 4 goes into 8 and 4 goes into 64. So let's try 4, okay? So if I did, is 4 times 4 times 4 equal to 64? 4 times 4 is 16. 16 times 4 is 64. So in this case, my x would equal 4 because it's saying 4 cubed is 64. All right. I should probably outline these so we know what I'm doing here. Oh, I'm all over the place. All right. So I've used 2 of the numbers. They have to be on one of these numbers, so it shouldn't be too hard to figure them out. Like you can do trial and error. All right, this is saying 2 to some power is 32. Now here's how I would figure that out. I would say 2 times 2 is 4. That's not 32. Times 2 more is 8. That's not 32. Times 2 more is 16. So this was 4. This was 8. This is 16. Still not there. Times 2 is 32. Oh, that worked. Now, it's asking me for the exponent. So how many 2's did I multiply by itself? I multiplied 1, 2, 3, 4, 5. So this was 2 to the 5th power, which meant x was equal to 5. Okay? So it's saying how many times did I multiply 2 by itself to get to 32? Okay. This one I just got to figure out. Okay? What color when I use blue? It's 2/5 to the 3rd power. So it's 2/5 times 2/5 times 2/5. And I'm just going to multiply it out. 2 times 2 is 4. 4 times 2 is 8. 5 times 5 is 25. 25 times 5 is 125. X is equal to 125. Okay? All right, this one's a little tough. It's asking me x squared is equal to 16 over 9. Okay? So it's saying some number times itself, some fraction times itself is going to equal 16 over 9. What number times, I'm going to look at the numerator. What number times what number gives me 16? Okay? So I'm going to think about it. It has to be the same number. So 2 doesn't work, 3 doesn't work, 4 does. So if I did 4 times 4 over what times itself gives you 9, that would be 3 times 3. So this is 4 squared, 3 squared. So that means this is x squared. This is 4/3 squared, which is what this is. So that means x was 4/3, okay? So what I had to figure out is what number can I multiply by itself to give me 16 over 9? And that would be 4/3, okay? All right, this one should be a little bit easier. If I have, oh, I did 2 in blue. Jeez, losing my mind. Sorry. I'll move on to purple. All right, so this one, it is saying you have 2 times 2 to the 5th. I'm just adding one more 2 to my exponent, okay? So I could really say that's 2 to the 1 plus 5 is 2 to the 6th power, okay? Because if I took 2 to the 5 and I multiply it by one more 2, I get 2 to the 6th. So on that one, x was 6, because it's asking me what power would that be, okay? All right. This one says 2 times what number is going to give me x to the 4th. So 2 times what number is going to equal 2 times 2 times 2 times 2, okay? 2 times 2 is 4, times 2 is 8, times 2 is 16. So I'm saying 2 times what is going to give me 16, okay? That would be 2 times 8. So x in this one is equal to 8. All right. So it's just a little bit of writing it out and thinking it through a little bit. This one I'm saying, okay, 4 times 4 times 4 is equal to 8 to what power, okay? Well, 4 times 4 is 16. 16 times 4 is 64. 64 is equal to 8 to what power? 8 times 8, so try it out. 8 times 8 is 64. I'm already there. So that means it's 8 to the 2nd power. So in that case, your x was equal to 2. Forgot to underline that guy. Okay? All right, we are not doing the are you ready for more? Okay? So look that over. You can print out the notes, remember, if you get stuck, and you can look at the video again. All right? So we're not doing any of the lesson 4. We're starting out on ending up on an easier thing here. Here's your lesson summary. It just kind of goes through everything we just did, okay? Talking about when you replace the x or you substitute. So that's where we're working with substitution. That means substituting in a number for x. Substituting a number for x. And seeing what it's equal to, or whatever variable, okay? All right, that's it for today. You have one assignment to do, and then that is the last Learn Zillion lesson before Easter break. I hope you guys have a fabulous Easter, whatever you celebrate and whatever you guys do as a family. Have a fabulous time, and I'm hoping to see you after Easter break. We'll see how things go. Bye.